I dedicate today's keynote to my beloved mother-in-law, Helen Michael, who died on Saturday. At the ripe age of 91, I knew her for 32 years. Helen's life embodied everything this talk is about. It's about love, exchange, and the generous bearing of others. In Helen's home was this artwork, The Stages of Life, a hand-coloured broadside woodcut by James Catnack, created in 1830. It shows the 9 ascending and descending steps of human life, from cradle to grave, with events of birth, marriage and death in surrounding vignettes. It reminds us, before we begin the keynote proper, that human life has always been understood as a journey through nested systems of time, relationship, and meaning. No algorithm, no machine has ever made that journey. Only persons do. So I welcome you to my keynote, AI, Humans, and the Evolution of Sociotechnical Systems. In part, this talk was inspired by a 74-page book chapter for Springer Nature you can download freely from the internet and co-written with Canadian psychologist Jordan Richard Schoner. We are living through a moment of extraordinary acceleration, as has already been noted this morning. AI systems are scaling in capability, in reach, and in consequence. But today I want to begin with a simple claim, one that may sound so obvious to you, but is increasingly under pressure. The human being is not an optional component of a system. The human being is the center. This keynote is about holding that center, not sentimentally, not nostalgically, but structurally, rigorously, and deliberately, as we design, deploy, and govern AI in socio-technical systems. And I'll take you through 5 movements today. Life is a dance after all, and it takes 2 to tango. First, the question of the human. Second, the landscape domains that study humans in systems. Third, the 3 levels of AI integrated socio-technical systems. Fourth, the growing misalignment between the analog and the digital. And finally, pathways towards responsible stewardship. This is not just a technical discussion, it is about what kind of future remains possible, given the tools we've created. We begin with a foundational question. What is it that only humans can do? Because whatever the answer is, that is what must be preserved. Not optimized away, not automated out, not abstracted into metrics. Preserved. Machines can monitor, they can store, they can retrieve, classify, predict, and generate. They can do these things at scales and speeds no human can match. But they cannot love. Love, in the sense that philosophers, theologians, and psychologists have long explored, involves attachment grounded in shared vulnerability, in history, in the meaning that only a mortal creature can fully inhabit. A machine processes signals. However sophisticated the output, however warm the language, as we're listening to empathic AI these days, there is no one home in the way that matters for love. You might love your computer, but I guarantee you your computer does not love you. This insight has deep roots. The medieval theologian Richard of St. Victor, one of the great analysts of love in the Western thought, observed that love to be real must be mutual. And mutual love to be generous rather than possessive must open outward to include a third. He called this the condelectus, the co-beloved. This is not a religious claim. It is a structural claim about what persons are. Think about it. What are we? What are we doing? Only persons can love one another, and by that measure, no algorithm qualifies. The second thing, no algorithm qualifies. The second thing machines cannot do is generate shared vision through genuine solidarity. When two people stand side by side, something emerges from that orientation. It is what philosophers call unity, and no agent can will that for us. We cannot outsource the act of standing together, of asking of one another, do you see what I see out there? The third thing machines cannot provide is not just unity, but community in the full sense. Community is more than two people coordinating. It is people working as fellow humans, bound by something deeper than a shared task or a shared interface. It is the feeling of being known and of knowing others in the context of a common life. None of these things are optional features that we can do without. They are the substrate of what makes human existence meaningful, and they are precisely what is at stake as we design systems of increasing autonomy and scale. Machines can only simulate proximity. Artificial intelligence is artificial. Digital twins are just that, digital, not real twins, no matter how close we simulate. Novelist Charles Williams discusses this love as exchange. We live not just for ourselves, but from others and for others. He says, all life is vicarious. And note, he does not say all life is transactional. In our modern society, exchange means transactions, but really deep down, we bear one another's burdens, not as abstraction, but as a concrete act of substituted love. This interdependence is not weakness, it's not fragility. It is the very texture of what it means to be human together. None of this is available to a machine. An algorithm cannot stand beside you. An agent cannot be your co-beloved, even if you believe it is. A system can process information about your burdens. It cannot carry them. Just ask GPT. And this is why, as we design AI into ever more intimate domains of human life, caregiving, education, mental health, civic life, the question is not only what the system can do, it is what the system displaces. I want to dwell on this, on exchange and interdependence, because I think it is the most underrated concept in any honest account of what makes human life worth living, and the most underused concept in how we design. And how humans do not thrive in isolation. We never have. Anthropologists, developmental psychologists, and moral philosophers converge on a basic truth. Human flourishing is irreducibly relational. We need each other. We become who we are through others. We sustain who we are through continued exchange of care, of knowledge, of labour, of meaning. Remove the exchange and you do not have a simpler human, you have a diminished one. Kallistos Ware puts it with disarming simplicity. I need you in order to be me. Charles William again captures this structurally as the web of exchange that makes knowledge cumulative, culture transmissible, and civilization possible. It is not sentiment, it is the actual mechanism by which humanity does anything important. The risk we face is not that AI breaks this web catastrophically in a single moment. It is that it frays it gradually. Every time we replace a human relationship with a machine interface, we reduce the number of occasions on which exchange can happen. We reduce the friction, yes, but we also reduce the depth. And a world of frictionless surfaces is not a world of greater human flourishing. It is a world of lesser interdependence, which is to say, a world where fewer of the things that matter to us can actually occur. Humans are analog beings. We evolved over roughly 200,000 years ago as Homo sapiens. We are embodied, we fatigue, we forget, we trust slowly. Machines are digital. They iterate in hours, as we just heard, even weeks. They store across vast timescales. They retrieve instantly. They scale without embodiment. This creates a profound gap, a misalignment not just of speed but of being. Humans build trust through lived experience, but outsource to a machine that lived experience, and you don't know what that is. You don't even know what expertise is. Machines are assigned trust. Humans can love. Machines cannot. And yet increasingly we are designing systems as if these differences are negligible. They are not. They are the defining constraint of our age. To navigate this properly, we must be precise. There is not one field studying humans in systems. There are many, and collapsing them into one leads to confusion in both design and governance. Now, I won't share with you the intimate details of all the things you already know about human factors, ergonomics, sociotechnical systems, human systems integration and engineering, and systems engineering that is the broadest container of all. But I want to talk to you about public interest technology, a field that I helped to create in 2018 and develop the first inaugural Masters of Science in Public Interest Tech at Arizona State University. It emerged from civic technology movements, digital public infrastructure initiatives, and the growing recognition that technology design is always a political act. Public interest technology asks not only whether a system works, but for whom it works, in whose interest it was built, and what social values it encodes. It draws on human factors, on sociotechnical systems, on systems engineering, but its normative center of gravity is not user performance or system reliability. It is justice, accountability, and the health of democratic life. It is the field that asks, what does it mean to design technology that genuinely serves the public rather than extracting value from it? Alongside it sits purpose-driven innovation, of which also I have written about in Sociotechnical Systems. The practice of orienting the full innovation process from problem definition to deployment around a clearly articulated social or ecological purpose rather than around market opportunity alone. I'm not saying do away with the revenues or profits or cost optimization or regulatory compliance. I'm saying let's think of new business models that work for all. And social embeddedness, the insistence that technologies do not exist in the abstract, but are always embedded in technologies do not exist in the abstract, but are always embedded in specific social contexts, institutional arrangements, and relational webs that shape how they function, who benefits, and who bears the costs. Briefly, we now move on to the core analytical structure. AI integrated sociotechnical systems operate across three levels: the micro, the cognition; the meso, the organizations and sociotechnical systems; the macro, the national innovation systems. And confusing these levels leads to poor design and failed governance. A quick note: don't ignore any of these levels in your design process, even if not directly relevant to your project. At the micro level, we encounter the human mind, your brain. Working memory is limited. We know that incredibly, I see a lot of people tired these days and overwhelmed. Wellness in the workplace is a huge issue. And AI systems that overwhelm users degrade performance and productivity. Situational awareness unfolds in stages, 3 of them: perception, comprehension, projection. If users treat AI as a black box, they never move beyond perception. But what about the comprehension? What's really going on? And what about the ability to project? Trust must be calibrated. Overtrust leads to automation bias. Undertrust leads to disuse. Neither is safe. And increasingly, awareness is distributed. We talk about distributed situational awareness, DSA. No single human holds the full picture. Not the engineer, not the scientist, not the clinician, not the professor. If cognition is offloaded without understanding, we do not augment the human, we erode expertise, and we are seeing that in the workforce today as we have our graduates entering employment. At the meso level, sociotechnical systems, we move into organizations. Here, AI does not act alone. It mediates relationships between people, roles, and structures. The principle is joint optimization, not just technical efficiency, but dignity, sustainability, and social coherence. And crucially, participatory design. Stakeholders are not just users, they're those affected, they're those excluded, those governed by the system. Roger Clark of ANU calls these people usees, not just users. These include children, including marginalised communities. When sociotechnical systems fail, we see groupthink amplified by AI. I just believe what the AI tells me. That's the most available source, or sources in the open source dictionaries online. Cascade failures in tightly coupled systems where we've seen share prices crash dramatically and markets overnight, even in 45 minutes in some cases. Shadow IT emerging as workers route around constraints. No, you can't use this. I'll just get my phone out. These are not technical failures alone, they are social failures embedded in technical systems. And at the macro level, we must be very careful. This is not simply a larger socio-technical system, it's a different domain entirely. National innovation systems, geopolitical dynamics, regulatory regimes. Countries do not just adopt AI, they shape it through institutions, through markets, through ideologies, through economic systems. And governance is fragmented. Hard law like the AI EU Act in Europe, soft law like the OECD principles, even standards like ISO frameworks and other technical guidelines, let alone all the protocols. Meanwhile, AI evolves faster than regulation can respond. This is the technology pacing problem, and beneath it all lie material realities. Rare earth minerals, energy consumption, water use. AI is not immaterial, it is deeply entangled with the planet, and we cannot ignore the planet. When we look across these sectors, finance, education, health, and intelligence, that Jordan and I have written about in our case studies, we see the same pattern. AI amplifies capability and vulnerability simultaneously. You can't have one without the other. This is the nature of complex systems. There is no purely positive deployment, only trade-offs, but this cannot be a zero-sum game. We now return to the central tension, be a zero-sum game. We now return to the central tension. This is not something optimization can solve because it is not a technical mismatch. It is a civilizational one. That's the problem. Humans evolve slowly. As already noted, 200,000 years of biological history have produced us with an extraordinary capacities for empathy, language, creativity, and moral reasoning, and hard limits on our memory, on our attention and speed. Our social structures adapt over generations. Our institutions change over decades. Our individual expertise develops over years and years and years. Our biology is what it is. AI systems iterate in cycles measured in months, in weeks, in hours, in minutes. They can be retrained on new data, updated with new objectives, scaled to new contexts, and deployed globally without the friction that human change requires. They store information across timeframes that are, for all practical purposes, unlimited. They have no biological ceiling. They don't go to sleep. The gap between these two trajectories is not a gap that closes, it widens. And as it widens, the question of meaningful human control becomes increasingly urgent, because meaningful control requires comprehension, and comprehension requires cognitive access to a system's operations. And that access is precisely what autonomous and opaque, rapidly evolving AI systems tend to deny us. Billions of parameters in the LLMs. What's it doing? The imperative is this: machines can monitor, adapt, and store across timescales that humans cannot match, but they cannot choose human values. That is not an engineering limitation that will be overcome with more compute. It's a philosophical reality. Values require valuing, and valuing requires a kind of interiority that we have no reason to believe current or near-term AI systems possess, no matter what the marketing says. That gap is not an engineering problem, it is a stewardship problem. And working together with the tools we've created, genuinely together, with humans setting the direction and machines serving as instruments, the hope is for a future where we do not extinguish the human race through the careless delegation of judgment to systems that have no stake in our survival. Machines don't care. I do not believe fusing the biological with the technological is the answer, despite what neurotech promises. I've been studying it for 30 years. One of my research areas is implantables. For 7 years, I worked as a telecommunications engineer for Nortel Networks, and prior to that, for consulting companies. I'd prefer to listen to the experts like Professor Christopher Tomazu of Imperial College London, who has repeatedly said, let the biology do what it does best and interface the digital on the outside. This does not mean I negate our biomedical marvels like deep brain stimulation and other vagus nerve stimulation devices and so forth. There are elements that must remain irreducibly human: love and genuine care, unity between persons, community as co-beloved fellowship, moral accountability, critical contestation. Accountability cannot be outsourced. Judgment cannot be automated. It's not somebody else's problem, it's our problem. And the ability to question systems, to interrogate them, override them, must remain intact. We have unaccountable ones if we do not have intelligence. Consider the Murray-Darling Basin. I'm shifting here. It's a case study I've introduced to my MBA students in the new degree at the University of Sydney Business School. The Murray-Darling Basin, Australia's most significant freshwater system, spanning 4 states and 1 territory, sustaining agricultural industries with billions of dollars annually, supporting the water security of millions of people, and underpinning some of the continent's most ecologically significant wetland systems, including Ramsar-listed Coorong and the Macquarie Marshes. This is not merely a hydrological system, it is a socio-ecological system, a deeply entangled configuration of human decisions, institutional arrangements, cultural attachments, and ecological dynamics. The Basin Plan, the federal instrument that governs water allocation across the Murray-Darling, represents one of the most ambitious attempts anywhere in the world to apply sociotechnical systems logic to an ecological catchment. And the University of Sydney is one of the main sponsors of the CRC, called One Basin. It tries to balance consumptive use by irrigators, environmental flows for ecosystem health, First Nations water rights and cultural values, and the long-term sustainability of a system under increasing climate stress. Every one of these is a legitimate claim on a shared resource. None of them can be satisfied by optimizing for any single stakeholder. This is the socio-technical systems design problem in its most literal and most consequential form: joint optimization across competing socio-technical, ecological, regulatory, and temporal subsystems in a context where the system boundary is not an organization as we know traditionally, but it's a river basin, and where the consequences of failure are not measured in downtime or lost productivity, but in the death of rivers, the collapse of communities along the river basin, and the extinction of species. AI is now entering this space through the University of Sydney and its partners. Remote sensing, predictive hydrology, automated metering, AI-assisted compliance, monitoring, and all of these are being deployed or trialled in the basin. And the STS questions are immediate. Who has legitimate access to the data? Whose models of the system are treated as authoritative? And whose experiential knowledge is discounted? How do you build participatory design into a governance process that already struggles with the power asymmetries between large irrigators, First Nations communities, and environmental advocates, and the government itself? And when the AI system recommends a water allocation decision, who is accountable for the downstream consequence, human or ecological, if it turns out to be wrong? This costs money. This has implications, social implications. The Murray-Darling is not an edge case. It's a prototype of where our attention should be. As climate change places freshwater systems under increasing stress worldwide, the challenge of governing shared ecological resources through sociotechnical systems with AI as an active participant will become one of the defining governance problems of the century. The Murray-Darling is not a pipeline to be optimized. It is a living system and its own dynamics, its own thresholds and its own irreversibilities. For some, the Murray-Darling is a living ancestor. What do we choose to do through exchange between disciplines, between communities, between timescales? Is not a design nice to have for ecological sociotechnical systems. It is the precondition of their survival. So what do? We shift from deployment to stewardship, and we focus on human-centered design principles, of which I won't labour on. You can read about them in our book chapter. But we must also rethink our goal. Not optimization, but resilience. Not static systems, but systems capable of adaptation without collapse. Not efficiency alone, but human flourishing. There is still much we do not know. At the micro level, how cognition changes under continuous AI interaction. At the meso level, how organizations retain memory when both humans and AI are learning and changing. At the macro level, how we govern across jurisdictions without losing accountability, and ethically, how we include non-human considerations without losing human control. These are open questions, and they will define the next decade of research. But before I close, I want to share with you an illustration of a distinctly Japanese way of thinking. In the early 17th century, the feudal lord Matsudaira Masayuki commissioned a great cedar avenue to line the road to the Nikko Toshugu shrine in the mountain north of Edo. Commissioned a great cedar avenue to line the road to the Nikko Toshugu shrine in the mountain north of Edo. He could not afford the gold and lacquer that the other lords could afford. What he could give was trees. He planted them knowing he would never see them reach their full height. His son would not see it. His grandson might get a glimpse of it. But the avenue he planted is this one, and it contains 13,000 cedars, many over 400 years old, and it is designated both a national treasure and a UNESCO World Heritage Site. He gave to the future what the present could not yet receive. This disposition, long-term, that system's thinking, long-term, I say it again, long-term thinking, intergenerational, patient, oriented toward what will be rather than what is, has a name in Japanese thought. It is part of the philosophy called Sanpo Yoshi, the principle of good for the seller, good for the buyer, good for society. I end with the story because the challenge we face with artificial intelligence at its deepest is not a technical challenge, I say it again. It is a temporal and relational one. We are building systems that operate on timescales of milliseconds. Matsudaira Masuyuki planted cedars. We are planting algorithms. The question is whether we are thinking with anything like his patience, his humility, or his sense of obligation to those who will come after. And to think clearly about that, we need to have a framework for scale. From the universe, the physical and ecological conditions that make any human life possible, to the nation, with its regulatory regimes, innovation ecosystems, to the university, or the corporation, the institution in which many of us work, which is itself a socio-technical system, to the family, the primary unit of intergenerational exchange, and the context in which most human values are first transmitted, to the person, the irreducible centre of moral consideration, and finally to each of our brains. Guess what? Each of us is a species that borders on extinction every day. You are unique. Your brain is different to everybody else's. How do we maintain that? It's the biological substrate in which cognition, memory, meaning, and identity are instantiated. Every AI system operates across all of these levels simultaneously. It was conceived inside a university, funded by national innovation policy, governed by regulatory frameworks, deployed into families and communities, used by individual persons, and processed ultimately by our biological brains that evolved for an entirely different world. Any analysis that addresses one of these levels is incomplete. Any design that optimizes at one level without attending to the others will produce failures at the levels it ignored. That is the core argument of this keynote, and the reason we need socio-technical systems thinking, not just AI engineering. Now let me end where I began. AI cannot be separated from the systems in which it is embedded. And those systems cannot be understood without placing the human at the centre. So we must remember, humans love, machines cannot. Unity exists between persons. Community is co-beloved fellowship. Human evolution is slow, really slow, and these machines are really fast. How do we get that gap closer when it's widening? And the goal is not optimization in the traditional sense, it's resilience, anti-fragility, it's justice, and human flourishing. If we get this wrong, we risk building systems that outpace us and erode the very conditions that make us human. If we get it right, we have the opportunity to build a future where humans and their tools work together in harmony, not toward efficiency alone, but toward a shared and meaningful existence. Thank you.